This video is for 8th grade math, section 7.4, and we are talking about properties of similar polygons. We have a few terms I want to go over first before we get into the lesson. I encourage you to take notes on this so you can go back and look at your notes while you're working on your homework. So the first term we need to go over is similar polygons. What are similar polygons? Well, they are just polygons that have the same shape. Okay, these are typically different sized polygons, and we're going to talk about what these maybe look like. Our symbol for similar is a little squiggly line. We might say that triangle ABC is similar, like that, to triangle XYZ. So that's our little similar symbol. This is different than congruent. Congruent means that they are the same shape and the same size, and similar just means that they're the same shape. The second term we need to talk about briefly is scale factor, and a scale factor is the ratio of the lengths of two corresponding sides of two similar polygons. And we're going to talk about what that looks like a little bit in more detail here in just a little bit. Okay, on to some maybe pictures of this. So this is what similar polygons might look like. We have two things that need to be true. Their corresponding angles are congruent. Okay, this is the same as it is for congruent shapes or congruent polygons. Their corresponding angles have to be congruent for both. Now, the difference between congruent polygons and similar polygons is that similar polygons have the measures of their corresponding sides have to be proportional, whereas congruent polygons, your sides have to be the exact same length. So that is where similar and congruent are different. So they're different sizes. They have different criteria there. Okay, you can see right here, we've got triangle ABC is similar to XYZ. We have our little similar symbol. And then with this proportional side thing, this is kind of what they're talking about here. They have this is where they talk about the angles, but the proportional sides is just as like, they're saying, well, you could put AB over XY should be the same as BC over YZ. And we're going to look at some examples of that in just a little bit. So, first example, determine whether rectangle HJK is similar to rectangle MNPQ and explain. So, similar, remember, means corresponding angles have to be congruent. So let's check that. Are our corresponding angles congruent here? Well, yes, they should be, right? All of these are right angles, and so that means all of them are congruent to each other. The second thing we look for is that the measures of their corresponding sides are proportional. And what does this actually look like in a problem? Well, let's set this up. Let's start with HJ and MN, because those are our first two letters we've got here, HJ, MN. And we can say 7 over 10. That should be equal now to JK over NP. JK over NP over to 3 over 6. This is our, if these are equal, that will be our scale factor. Let's check and see. Let's reduce 3/6 to 1/2. Let's reduce 7/10. Well, it doesn't reduce, so it will stay 7/10. Does 7/10 equal 1/2? No. So we were going to say that no, HJKL is not similar to MNPQ. And then our reasoning, we could just circle this also as part of our answer. So those are the two parts to our answer. You could also say something like the sides don't have the same scale factor, but I will accept this as an answer. Let's do another one. Determine whether triangle ABC is similar to triangle XYZ and explain. So let's set up our ratios again. We don't have any angle measures on this one, but I believe we can just assume that they are Actually, we can't assume that they're the same, okay? Because they're not marked. So right away we can say no. Corresponding angles are not congruent. But let's check the side lengths just to see. Okay, and if the corresponding angles aren't congruent, I don't think the side lengths are going to be, but let's double check. Let's put 6 over 8 and then should equal 8 over 12, okay? 6 over 8 equals 8 over 12. Let's reduce these. 6 over 8 reduces to 3 over 4, and 8 over 12 reduces to 2 over 3. So 3/4 does not equal 2/3. We can circle both of these here. We could also say something that like our side lengths are not proportional to each other. Okay? Moving on. This one is telling us that these two shapes are these two shapes are similar. So let's find a side length here. We're going to need to use our scale factor. So first we need to determine what our scale factor is, and the immediate thing we should probably do is see, is there a side length that's from ABCD that's corresponding to WXYZ? And we would say yes. Well, 10 and 15 correspond, so we'll set that one up. And our challenge here is to find XY, which looks like M right there. And then the next question we would ask is, okay, what side length corresponds to side M? And we would come over to ABCD and say, well, 12 does, right? BC and XY look corresponding. You can check these angles. That has 2. This has 3. This one has 2 arcs. This one has 3. So those two are corresponding. So to solve this, we might say something like 10 over 15 equals M over 12. And now we need to solve for M. Now I would reduce 10 over 15 maybe to 2/3 or something. If you can't reduce, that's okay. And this is how we're going to go about solving these. Okay, let's take this equation here and ask it. I always like to ask the question, and you guys know how to answer this, or you know how to ask this too. What are we solving for? Well, we're solving for M, and what's happening to the M? It's being divided by 12. To undo division, we need to multiply. So we need to multiply this side by 12, multiply this side by 12. Those ones cancel out. On the left side, we have 12 over 1 times 2 over 3. 12 times 2 is 24. Divided by 3 equals M. 24 over 3 is 8. Okay, and our missing side length then should be 8. Let's do a couple more of those. We want to find WZ. So let's use our same ratio of 10 over 15 right here. We're going to reduce that again to 2 over 3. Okay, we need to find WZ, which is this guy right here. And our corresponding side length is 13. So we'll say 13 over WZ. Just call it that. Now this one might be a little bit more difficult to solve because our WZ is on the bottom of that equation. So let's multiply by WZ on both sides. Okay, those ones are going to cancel. And now we need to multiply by the reciprocal over on the left side. So multiply by 3/2. Multiply this one by 3/2. Now 3/2 times 2/3, this all reduces to 1, right? So we should get WZ equals 13 times 3 is 39 over 2. And that is our side length. Now to find our other side length, AB. And as I was going over that, I realized I made a mistake on that last slide. Okay, so disregard the last slide. This slide is going to be much more helpful to you. Okay, let's use the same ratio again, 10 over 15. This time we need to find AB, this guy, and 24 corresponds to that. So we're going to say AB over 24. Let's reduce 10 over 15 to 2 over 3 again. So 2/3 equals AB over 24. To solve for AB, we need to multiply by 24 on both sides. Reduce this to 1. 24 times 2 is 48. Divided by 3 is AB. And 24 divided by 3 is 16. So that one worked out really nicely there for us. So we can circle those two answers. Again, this is what is on your homework today. If you have questions on this, please make sure to send me a text, a remind text, or an email about this. And if need be, we can schedule a Zoom call to go over any questions you might have.